to see everyone, and it's great. The four of us up here could talk to you about math for probably months, actually. And but we know that we have to keep this succinct, and that means that we can't tell you everything that we would love to tell you. So we've decided to try to keep it to about 10 minutes apiece, which roughly covers the span from kindergarten to 8th grade, of an overview of our program. And there'll be time at the end. That will allow us to give you time at the end for you to ask questions. So, be thinking about those questions that you might have, and some of them probably will be answered as we talk. If you have a pencil or something, you could jot them down. If you don't, that first drawer, well, actually, that's probably not true. The first cabinet, as you walk in my math lab over there, on the upper, there's definitely all kinds of writing implements in there. In all of our classes, I think the most important thing, and this is a trajectory that goes from kindergarten through 8th grade, is developing the habits of minds of a mathematician. And those habits of mind are very similar to other disciplines. You'll recognize them no matter what discipline you're in. But we want kids to develop these habits of mind, to bring to their work in a mindful way, so that they are approaching their mathematics as true problem solvers. So what are some of those things? Well, first of all, curiosity is the first thing. You have to be curious. You want to persevere. You need to realize that you're not always going to get there the first time you try something. You want to be able to reflect and revise. You want to communicate and listen to others carefully, and have others listen to you carefully. You want to be risk takers. You want to sniff out patterns. I mean, many people would say that along with the fact that mathematics is the language of science, mathematics is the language that allows us to quantify and measure and understand our physical world, patterns are at the heart of it. And understanding and identifying patterns is really the very nature of mathematics. We want them to tinker with ideas, to play around, to be thinking in different ways, to be coming from different angles, various approaches to what they're doing. We want them to think flexibly, to consider alternative approaches, and make plausible conjectures. And all of these things are at the heart of just being a person and understanding the world. These habits of mind take time to develop. You can't teach somebody how to develop them. You have to immerse them in an environment in which those are the expectations. That is how the classroom runs. That the discourse that goes on is infused with those expectations. And so that is what, if you were to walk into any of our classrooms, you would notice. They're probably very different than many of the classrooms that you yourself had in mathematics, and or very different from others that you would see even today if you were to walk into a more traditional mathematics classroom. I'm going to show you, I don't like PowerPoints for reading text, but there's some points that I want to make that are really, really important that I've talked about at times, and I feel like it's sometimes good to see the words. This is a quote that from Li Ping Ma, who is a Chinese math educator raised in China, had a very interesting background, but came to America to do her graduate dissertation and compared Chinese education in mathematics to American education. This is back probably 25 years ago. But I think this is at the heart of what all of us who teach mathematics at elementary level feel, that you really have to understand it deeply in order to teach it. And I think that if you look up here at the four of us, that's probably what we spend the good portion of our week doing, is I'm trying to figure that out. I'm taking this from the book that some of you may be familiar with. James Hebert, who's here at the University of Delaware in math education, wrote a book. This is out of the TIMS study, which was International Study of Mathematics and Science, and it's making sense of mathematics. And they studied math classrooms all over the world. And they looked at urban and rural and suburban, and they looked at, I think, Germany, Japan, America, can't remember where else. And they kind of looked at what made a powerful mathematical classroom. Where were the kids coming out who really understood mathematics, really understood it, And these were the three things that came up with that mattered: the types of tasks, the role of the teacher, and the culture of the classroom. And these things are really important, and again, I want to say that this is the backbone of what we do here when we think about creating our math program. There's some resources on the table as you came in, you might have noticed. So I'll start with the tasks, and I'm not going to read this for you, you can read it, but briefly I'll say they're sequential. They have to build on the real, true understanding and the big ideas of mathematics. They're not random. They're not, oh, let's have a fun math lesson today. They have to have the essential mathematics ideas in them. And they have to be accessible to all students. There has to be an entry point for students to get in to problem solve. The teacher has to have the knowledge of what that is, not only of the mathematics, but of how children learn mathematics, which I think is the thing that eluded many of us, even those of us who went through teacher education, was that the way that people think mathematically and children think mathematically is not as apparent as we might think it is. It's very complex and very interesting. We have to provide the relevant tasks, and we have to provide the conventions of mathematics, the coding, those things that they're not going to know themselves. And we have to establish the culture of the classroom. And the culture of the classroom has to be where thinking and reasoning is the expectation. Not just coming up with right answers and fast answers, but thinking and reasoning, all those habits of minds that I talked about at the beginning, that has to be the expectation. That you really are throwing yourself in there and wrestling with those ideas, and that you want to be risk takers, you want to struggle, you want to persevere, you want to go down a path and see if that one's going to work, and if it doesn't, come back. You want to communicate, so communication is essential. You would see that in all of our classrooms if you come in. It's talking, it's a forum of discussion. They're convincing each other of their thoughts, they're listening carefully, they're doubting, they're questioning, and that mistakes and errors are viewed as a place to learn, a time to examine faulty reasoning. So the mistakes are the natural part. We expect that kids are going to, in rough drafts of writing, make all kinds of mistakes and edit them out. But often in mathematics, we don't allow that same kind of mistake. The mistakes are very, very important. I'd much rather have kids come in to my classroom with mistakes in their homework that we can talk about, because that's what we talk about the first thing is, anybody have any questions? What did you find, any troubles? What do you have? And somebody will say, well, I didn't quite understand this, or I didn't get that, or I tried it, but I don't think I got the right answer. And that's what you want. You want that openness, because that's the way they're going to learn how to hone it in. They want to hone it in to be more precise, to be more accurate, but you have to give them a chance to do that. So tonight we'll be going through, we'll start with Kelly because she's at the younger and go through. I think that's a trajectory that probably makes the most sense. And so much of what is crucial at that young level is what Kelly is dealing with on a day-to-day